In the last few videos, we've covered some of the basics of scramjets. And in the next few, we're going to go further and deeper. If you are serious about learning about this subject, you will want to use these videos with other materials which will broaden and deepen your understanding. So this video is aimed at directing a serious student to useful study resources. I split this up into two sections, one about books and written material and the other about available internet resources, especially those on YouTube. Firstly, these videos assume that the watcher has a working knowledge of fluid mechanics. However, if you don't, or if you want to brush up on this, there are numerous books you can refer to. And any basic book on fluid mechanics will do, but my own personal favourite is Douglas. Full references to all the books and papers mentioned here are given in the video description below. For a more in-depth view of aerodynamics and a good treatment of isentropic flow and shock waves, the series of classic books by Anderson is recommended, especially Aerodynamics and Modern Compressible Flow. For a good treatment of nozzles and all aspects of rocketry, the classic text by Sutton is recommended. If you're interested in the history and development of scramjets over the time since they were invented, then the paper by Curran on the history of the subject is very good. It's rather dated now, but contains a history of scramjets up until about the year 2000. Finally, we have the classic book on scramjets, Hypersonic Airbreathing Propulsion, sometimes called HAP for short. Despite this book being a little dated, it really is an essential text. It's sometimes available second-hand on bookstores like Amazon at a reasonable price, and electronic versions are available through some libraries. It's beautifully written and easy to follow, and covers all the important scramjet theory, although do bear in mind that because it was published some time ago, some of the material is a little out of date now. Let's now turn to internet resources. One simple and obvious one which is worth reading is the Wikipedia articles on scramjets themselves, but also on the other related topics which are involved in scramjet design. YouTube has a good animation of the X51A Pratt & Whitney Scram demonstrator, which will help you to visualize its layout and operation. Some of these internet resources I will reference at the top right of the screen, and if you click on the exclamation mark there, you'll find links to the videos. NASA has a small number of very useful pages discussing a variety of topics, including scramjets, but their pages on shock waves are particularly good and useful to get the basic equations and an understanding of how shock waves work. There are a series of lectures from the Indian Institute of Technology on the subject of nozzles and flow through diverging and converging ducts, subsonic and supersonic. And these are quite long and presented in a rather old-fashioned way, but are rigorous and will give you a good idea about the equations and the issues involved in nozzle flow. Finally, we come to the most important video resource. That is the edX course on scramjets from the University of Queensland in Australia. This is an excellent resource and several topics are covered. In fact, they're covered so well that I've decided not to cover them again in these videos. In particular, the videos for Week 1, which is general information about scramjets, and Week 2 on scramjet intakes are excellent and highly recommended. These are available on the channel as playlists so that you can play the appropriate videos in the correct order. The sections on nozzle flow and combustion aren't quite as good, but are still a useful supplementary discussion.